about molarity. Now, molarity is a specific way to actually calculate concentration. If you remember, concentration is specifically talking about how much solute is dissolved in a solvent or a solution. Now, molarity is a specific type of it. Now, I want you to look right here. Do you see how molarity has the word mole in it? That's significant. That means that when we're calculating molarity, the units matter. And when I'm talking about exactly what students do that mess up that cause them to lose points, is when they don't pay attention to the units. So please, please, please be careful that you're watching units here. I'm going to work through 3 examples so you can see exactly what I mean, but units are what the hardest thing about this is. So molarity is a way to calculate concentration. It specifically is moles of solute divided by liters of solution. And molarity, we abbreviate it with a capital M, and the unit for molarity is also a capital M. So you'll have a capital M at the end of the number as our unit. And it is the same as moles per liter. Moles per liter. It can't be grams per liter. It can't be moles per milliliter. It has to be moles per liter. So as we're working through these problems, I'm going to really overemphasize those units because I really want you to get this right on your quiz, on your test, whatever it is. I want you to get this right. So we're definitely going to do some practice, but make sure you know this. By the way, this formula is in your reference table. You just have to be able to know it's there and how to use it. So let's get some practice. First problem is, what is the molarity of a solution containing 5.85 grams of potassium iodide in 125 mils of solution? So we're looking for molarity. The first thing you should do is you should write the molarity formula. Molarity equals moles per liter. Okay, now let's look at the problem. We've been given moles per liter. A solution containing 5.85 grams. That is a mass. So can we plug that directly in here? We cannot. But if we know the mass, we learned a few units ago exactly how to calculate the moles. So we're going to have to do a mole conversion here. Of potassium iodide in 125 mils, there's the unit. Is milliliters here? No. We're going to need to convert this from milliliters to liters of solution. So we're trying to find the molarity, and unfortunately, both numbers we've been given don't match the units we need. So before we do anything, we need to do a mole conversion. Here's one thing I want to warn you. If you're not doing a mole conversion, there's a very good chance that you're incorrect, because most of the problems I give you are going to require a mole conversion. So there's my heads up there. Okay, so let's convert this to moles. So 5.85 grams. Now potassium iodide we're going to have to put in a formula. Potassium is a +1. Iodine or iodide is a -1, so we just need one of each. Okay, we're going to set up our conversion here. You remember whatever unit's on top is going to go on the bottom next time. And we need to convert to moles because our problem requires moles, and it's always going to be 1 mole. Now, do we remember where to get this number? We've got to use our reference tables. We have to use our periodic tables. We're going to add up all the individual molar masses of each of the individual atoms, and that total number is going to be our molar mass. So pull out your calculators, because we're definitely going to need them. Okay, so pull out these calculators, work through it with me, so you can make sure you can do it by yourself on test day. Okay, so potassium is 39.10. And iodine is 126.9. When we add those up, we get 166. That's the number of grams per mole. 166 goes right there. So do you remember what we do? Since it's on the bottom, we have to divide. Go ahead and do that. And we get, when we divide these, we get 0.0352 moles. Okay, now you see we've got moles here, we have moles here on the top. So now we are ready to plug in that top number, 0.0352 moles. Okay, divide that by liters. Okay, let's look at our volume. We were given mils. We have to convert that to liters. Now what I'm going to tell you is this is going to be a conversion you're going to do many times. You can set up your dimensional analysis if you want, put mils on top, mils on the bottom. There's 1,000 mils in 1 liter. I'm going to tell you, it's 3 decimal places. So if you remember that, there's the decimal now. If you remember to move that decimal place 3 times, then you can kind of skip a step. You can do it in your head. I'm giving you permission to do that. So we're going to move that decimal place 3 times. 125 mils equals 0.125 liters. And that's what we're going to put down here on the bottom. Now, my honors kids, I want you to notice here, because I need to take some time to talk about sig figs. Academic kids, I never taught you about sig figs, so you don't have to worry about this. But honors students, 3 significant figures here, 3 here. So we're dividing. Our final answer needs to have 3 significant figures, so please don't forget about those sig figs as you're doing your calculations. That's why I wrote 0.0352. It would be best if you don't round every time you write a new number. Consider sig figs, but use your answer function in your calculator so you're not messing up that final answer more than you need to. So we're going to divide these, 0.0352, divided by 0.125, and we should get 0.282 molar. Molar. Capital M is your unit, and the way you say it is actually molar. Now, sometimes my students want to do this. Let me make some room. Sometimes my students want to say the answer is M equals 0.282. That's wrong. I mean, the units are wrong. Because you really should say the molarity equals 0.282 molar. That's what you should say. There should always be a capital M at the end of the number. So please, please, please watch that. Okay, let's do another one because, like I said, those students usually get stumped up with these units. So let's just give ourselves more and more practice to get this done. I'm racing to make some room. Okay, here we go. Problem number 2. How many moles of H2SO4, that's sulfuric acid, are present in 500 mils of a 0.150 molar solution? Oh, see, here's something that's nice. Do you see how this problem is asking for moles? I'm going to put a smiley face, because that means we don't have to do a mole conversion. Woo woo! And I'm always happy about less work. Don't get used to it. Almost every problem will require a mole conversion. We just got lucky on this one. Okay, so here is our molarity, and we're going to do molarity equals moles per liter. Molarity in this case is 0.150. We're trying to find the number of moles, and oh, we were given milliliters again. Remember, we have to be in liters. We are going to move that decimal place over 3 times. 0.500. And honor students, take note, that little decimal point is there telling you that there's 3 sig figs. So that's why I went ahead and wrote those extra zeros. Academic kids, don't worry about why I did that. So that's going to go on the bottom here. Okay, now in order to solve for moles, we've got to multiply both sides by that 0.5. These cancel, and the number of moles is going to be 0.5 times 0.15, and that's going to be 0.0750, and that's moles. Okay, now, remember 3 significant figures, honor students, that's why I added that extra 0. Academic folks definitely don't need to put that in there. Cool? Okay, let's do one more. What is the mass of NaCl in 240 mils of a 3 molar solution? Okay, now, let's see what it's asking for. It is asking for mass. Do you remember that mass has a unit of grams? is grams in our molarity formula? No. So we're going to have to do a mole conversion, but we're actually going to have to end with the mole conversion. We're going to calculate the moles. Then we're going to use the moles to find the mass. So we're going to actually have a mole conversion at the end of the problem. Okay, so we have 3.00 molar equals, molar solution equals the moles per liter. And oh look, we're given milliliters yet again. We got to move that decimal place over 3 times. And we're going to get 0.24. Okay. Multiply both sides by that 0.24. Okay, and for the moles, we get 0.72. And what is that? That is 0.24 times 3. We get 0.72. Do you see how the problem's asking for mass? We just calculated moles. We need to do a mole conversion. So, let's set up our little dimensional analysis. Cross. Whatever unit's on top goes on the bottom. 1 mole equals grams. And how do we get this? You got it. Woohoo! Our handy dandy periodic table. Add up all those individual atomic masses to get a molar mass of sodium chloride. That is going to be 22.99 plus 35.45. We get 58.44. Can I tell you? The most common mistake that students make on these problems is they would get this answer, 0.72, and that's what they'd circle. They would stop there, not even think about the units. What I want you to do is, as you're working through these problems, circle the units. Circle what you're looking for, point out what you were given, and anytime you see mass or grams, think mole conversion. That's what you're going to have to do. And 0.72 times 58.44, that's going to equal our 42 grams. There you go. And that is how to calculate molarity. Make sure you're looking at the units.